Assalamu alaikum Shabab. This is our experiment number 5, which will be on corona and its characteristics. So this is basically the table which I have made. So we'll be recording here first of all temperature, because corona depends on the pressure and temperature as well. So we'll have first part of this experiment will be confined to this table only, and this is transmission line surface conditions, and it will be under two conditions, smooth and rough. So we need to measure the onset voltage, that is the voltage at which corona starts on the transmission line. So we'll be writing comments here. So the method of detection of corona, as Dr. must have explained to you, is when there is corona on the transmission line, you have a radio interference being created. Okay, that radio interference will be detected by the radio. So our detecting source will be radio. So we'll have first transmission line and under good condition and smooth condition, and corona depends on the conductor radius and how much smooth it is. If it is not smooth, and it will have corona onset will be at lower voltages, and if it is very smooth, so it will be at higher voltages. So we'll be first completing this part of the table. Let's go inside the lab. You can see this is the transmission line here. So this transmission line will be at high voltage, so it is connected to the HV source there, which you can see their source, this HV source, this AC transformer. So it's a divider, and this is one end of the transmission line, and this is the second end of the transmission line. This transmission line now is smooth without any rough surfaces on the transmission line, and we need to measure the height of this transmission line. So this is 1 meter, 1.5 meter above the ground, so this will be needed for your calculation, and the diameter of this wire is 4.5 millimeter. So what I will do is now apply high voltage. So this time we don't have resistor in the series with our circuit because we are not making any breakdown, so we are just applying high voltage here. So this is basically your transmission line here connected to the AC source. From here, what I will be applying after I apply the voltage, so this is my radio here, so this will be my detection source. So once the voltage, I keep on increasing the voltage, when this radio starts detecting noise, so I will show you the noise, so that will be the corona onset voltage. So that is the voltage at which corona is being produced on this transmission line. So let's go inside and apply the voltage. See, there is currently no noise in the radio. So I'll bring you back once there is an onset voltage there. So I will switch on the voltage, sub on, and voltage up. So there is currently no noise, okay? You can see maybe you're able to hear the noise in the radio now. So this voltage is around 63 kilovolt. I will record here. So 63 kilovolt is the RMS voltage. 63 is the voltage when the conductor, there is corona on the conductor. So I'll take you to the radio inside and see there is a noise. See, there is clear noise, and maybe you can hear this hissing sound on the transmission line. So let me go inside and I'll switch off the radio, and there's an audible noise also which you can hear. And this noise you can hear now is basically an audible noise which is without any detection. Your human ear, it can easily detect this noise, this corona discharges from the transmission line. So next step will be, I'll make it rough so that there are some sharp edges on the transmission line, and then we'll take the measurements again. I have put this wire here to make some sharp edges on the transmission line so that this becomes a rough surface. So I will try again with the radio and see, because now the effective radius will be this one here. So this will be a sharp point here. So we'll see what is the effect of this roughness on the surface of the conductor. So we'll again apply voltage. And see what happens to the onset voltage. It's very dim noise, but this is at this 52 kilovolt. So it is not very audible here now, so I have to go inside. So let us take this as 52. So I will record on this here. So after sharp edges, so this becomes 52 kilovolts. So of course RMS. So you will just from my experiment, so this is the height and this is the diameter of the conductor. So write your comments, whatever you feel from this video. So write your comments in there, okay? Shukran. Okay, I will go to the next part later. Now Shabab, we are going to find corona onset voltage in a coaxial geometry. This is the coaxial geometry. So the outer part, outer cylinder, this one will be at ground potential, and these conductors, small wires, they will be put inside this one, and the diameter of this coaxial geometry is 10 centimeters, and the diameters for these individual conductors, so these are solid 1, 2, 3, this is 1.85, this is 1.5, this is 0.80, and one of them is a stranded conductor. So this is a sort of bundled conductor, so small wires, you can see they are bound together, twisted together. So you have this, the diameter, these are all diameters, 1.98, 1.50 and 0.80. So these all will be individually put inside this coaxial geometry, and then onset voltage will be found for them under DC voltages. So positive polarity as well as negative polarity. We may not be getting positive polarity as doctor explained in the theoretical class. This is it has few pulses in the peak, and for negative it's very the positive has lower frequency, while as this negative has a frequency in kilohertz range. So the procedure will be same, just change the conductor inside and then go to the DC source, apply DC source, and then increase the voltage till you find an onset voltage with the help of radio. So our detection source will be same as radio. So let me show you how to insert this conductor inside the coaxial geometry. Solid conductor inside, so you should go insert it from the bottom side and then let it sit there. Push it here, then once it comes out from the other edge, so just put it against your leg, push this down, okay, so there's a groove inside where it will sit perfectly. Just drop it down and this is fixed. Yeah. So this will be at higher potential, high voltage, and this outer cylinder will be grounded. So we have put 1.98 solid conductor inside and the outside will be grounded. So this is the chamber, actually you put it here, okay, then close this, put it here. So this will be our DC supply will come from here. So whole top of this chamber, as you did for SF6 also, so this will be at high voltage and the lower one will be grounded. Pause. So this is at high voltage and this one will be our ground terminal, which is going to the ground of the substation. So this high voltage line. Now this is our radio as did for the transmission line. So I'll just switch it on. Keep it a little bit away from this one. So I will increase the voltage.
Oh, megahertz.
No, this is in medium wave, medium wave. So our setup looks like this. So this basically this high voltage is coming from a DC high voltage from this cable. So this will be cable connection. Okay, this is our DC source. So I will just put it here. And this cable is coming from your DC supply, which is here. So this is our DC supply. So you can see this main cable which is going to the setup there. So this, as you know, DC has negative supply as well as positive supply. So this is connected currently. Now your polarity will be negative, and this is a return of the diode. So this return connection also, it is connected to the positive supply. So main, whatever the polarity, wherever this cable is connected, so that determines the polarity of the setup. So this cable, as I said, is going through this way and going to the setup there. So our setup is like this. So the brown two ones which you can see here, they are just this one and this one. They are just support insulators, just to support our high voltage connection. Now let's go to the setup there. Now this is our DC source, Shabab. So you have these three main, say 1, 2 and 3. So this is switching on the high voltage here. Now you have polarity switch here. So whatever the polarity, you can see from this one, this diode, this tank there. So it was negative there. So you have to put this as well negative. So if you change the polarity, so switch this manually to the polarity whenever you want to change the polarity. So this here has this is the meter where you are going to apply the voltage. So this has 3 ranges. So this is high is 0 ila 50, and then so it has 3 ranges: 0 to 10, 0 to 25, 0 to 50. So high is at 50. So we'll keep it at say, okay, leave it at high only, and then we have nothing to do with this current. So once these 3 breakers are on, then there is this high voltage on switch. So if you switch on high voltage, so you have this red indication that high voltage is on. So if you press off, so it is off. Now on here, now you can see the setup like this, complete one. Then when you press, once you this lamp is on, then you can voltage control. So you can raise, that's increase or decrease. So if I increase now, I keep on pressing this button, so you can see the voltage is increasing here. And you go on increasing slowly till you get a radio noise there. Okay, you can hear now radio noise there. You can see as I go on increasing, so the noise also increases. So basically you have to keep on increasing and then go lower it till this radio noise goes back again. So just fine tuning. There is nothing now, so I will just increase a little bit. See where it exactly starts. Okay, this is around 23 kilovolt. The polarity is negative. So this is my setup here. So the radio, you can see, is there close to the setup. So same thing applies. So you have to change the conductor and then find again for negative, then positive. Go on changing this. So I will take the readings because this video will be too long if I do it for all the conductors. So I will record them and give it to you. So let me stop here, and the next screen will be with the voltages. Okay, this is the table with the various readings for positive as well as negative. So as I told you, procedure will be same. So this one here is for positive polarity. Positive always is higher than the negative. As doctor explained you, its voltage and the repetition rate is in hertz, but this one is very clear in negative, so it is very and in kilohertz range. So that's why it's easy to detect negative polarity using a radio. So I have recorded these, so these you will use for your data. So this will be a data sheet for your, and the comments, whatever you can observe from the video, as I told you before, you add all this. The bundled, I have put two conductors in parallel together on the transmission line, which I showed in the previous video. So this is the reading for two conductors in parallel. So you write your comments there, and this completes it. Now the third part, I will make a setup, and then I will come back with the video again. Now Shabab, we have to find corona pulses, their shapes, to find their shapes, and for both positive as well as negative polarity. So this is basically my rod, so which will be at high voltage. So this is the cable coming from this power source there. So this is here, so this will be at high voltage and plane will be at ground. Now first, before you connect anything, any oscilloscope for detection of this waveform, you have to find the breakdown voltage of this gap. It should be far higher than the breakdown voltage, so that it don't get any breakdown in the gap. If you have a breakdown in the gap, whole signal will go to your oscilloscope and it will get damaged. So this is the ground point for this plane, and it is going through this resistor. So, and this cable is going to the oscilloscope. This resistor in the box, it is going to the ground here. So this is the ground terminal for this one. And let me explain you like this. So my connection is similar to this one. So plane at high voltage, sorry, this rod at high voltage, plane will be at ground, and I cannot measure voltage here, so I'm taking this voltage through the resistor, and then the current, sorry, I cannot measure the current here. So when there is a discharge, corona discharge in this, so there is a very small current flowing in this. So oscilloscopes, they don't measure current, so I will take this through this resistor, and whatever the voltage drop across this resistor, it will go through this coaxial signal, this cable to the oscilloscope. So there I will measure the voltage and divide by whatever the current, the resistance value. So this will be 50. So whatever peak value I will find in the oscilloscope, so I will divide it by 50, plus there is a termination resistance in the oscilloscope, so for that is for matching, so total will be 100 ohm resistance in the circuit. So whatever so to get the current, so I will say I corona will be whatever voltage value divided by total resistance is my 100 ohms. So that will give me the corona current, and from that current signal we will measure whatever the front values, tail values, and peak of the voltages. So this setup is just to give you a picture like this one. So you have rod plane gap clearly visible, and then this cable is going to my oscilloscope. So in previous experiment, previous parts of this experiment, we were using radio as source, detecting source, but now we will have this oscilloscope as a measuring device. So I will connect it there, I will apply the voltage, so when there is a hissing sound or corona, so I will find the onset voltage and measure the parameters of current, this corona currents. Okay, so I have switched on here, so I will increase the voltage. Now I have increased the voltage, so this is the voltage is around 37.5. So this is the voltage at which there is corona being produced in this gap. See, there is a hissing sound there, so that means there is already some discharges taking place, so some current is already flowing to the ground. Now how do I know there is actually corona or not? So we'll go to the oscilloscope end, where I can show you that there is already a pulse. So I will try to just measure that pulse there. Now see, this is the corona pulse for negative polarity. So you have this reverse. So if I try to make it smaller, so this is the pulse, so corona pulse. So my scale is 50 millivolts. So if you know how to measure the by these squares, so each division corresponds to 50 millivolt and the time base is for 50 nanoseconds. So let me first write down. So for this gap distance is not important, so we'll have, say, negative, the corona onset voltage was 37.5 kilovolt, and now we are going to measure this peak, time front and time tail for both these values. So I will calculate corona onset as corona current, whatever the flow of current there. So the main important thing is you have this corona pulse shape here. So there is already current flowing, so it is coming to the okay. After I have captured this waveform, I will just freeze this. Okay, waveform. Okay, now I have to find front time and tail time of the waveforms. So I will keep these are the cursors, two cursors. One is between, you can see this one longer one, this will measure the horizontal distance, and this small here, you can see the other small here, this will measure the peak. So I'll keep one at the zero starting initial portion of the curve, and then the other one I will bring at the top. So you can see this one here. So this is now here, say 149 this peak here. This is here peak. So I have here the voltage values. Okay, 158 millivolt, then 14.5 nanoseconds is the front time. And now if I take the half of these to this peak value, so that is 75, 76, like that. So that will give me the tail time. So from here to here, this is the difference between these two portions is the rise time, the front time, and from then I will keep this curve here and then bring this one to the half of the value, so 75. So I will just this switch, if you press this toggle here, then you can bring this you keep it here at the peak, and then this one you bring here. So this should be, the difference between them should be V peak by 2. So this is around, say, 75. So the tail time is now 31.5 nanoseconds. So this keeps on varying depending on the voltage values there. So the final values I will give you on this one. So similarly for the positive type of pulse, it will be upside down. So that will be, it will, like, say this is the negative, and then you will have positive upside down, and then same values you will do, find front time, tail time, peak values. So I will record for positive also, and then finally I will give you in the list of the sheet all the data in the recorded sheet, so that those values you will use for your report. Okay, this is your final data sheet, and you will have this, you'll use this for your record. So here I have shown you, this was the onset voltage for negative side, and this was for the positive, that's between the rod gap. So I got peak voltage, peak 148, front time 7 nanoseconds, 15 nanoseconds, and this is 148 millivolt, the peak value there, here, divided by 100 ohms in this resistor. So that gives you 1.48 milliamperes as the corona current. Similarly for positive, this is 38.5. This is the onset voltage. This is 2.85 volt, not millivolts. So you should be careful with this one. and then you will have 50 nanoseconds the front time and tail time 210, and this one is here 28.5 milliampere. So this was 1.5 and this is a 28 times more around. That's why the current in positive is very high, and even the peak of the voltage is very high. So thank you very much. Okay.